Hello, this is Mrs. Kohler, and today you're going to learn how to make a Punnett square. The first term that you need to know is called a monohybrid cross. Mono means one and hybrid means to mix up. So it's when you cross two individuals and see the outcome of a single trait. For example, you can mate a plant that has yellow peas to one that has green peas and then examine the offspring to see if they have yellow peas, green peas, or some have one and some have the other. And you would use a Punnett square to predict the outcome. So a Punnett square is a tool that predicts the probability that offspring are going to have a particular trait. So in this case, there's a probability that if this couple had children, 50% of their children would be big R, little r, and 50% of their children would be little r, little r. The thing to remember is that gametes get fertilized randomly, so your actual numbers might vary a little bit. The Punnett square just gives you the most probable outcome. In order to make a Punnett square, you want to draw a tic-tac-toe board, unless one's already drawn for you. And in the top row, you're going to put the first parent's genes. So this parent is big B, little b. You put them up top. Put the second parent's genes on the side. This one's homozygous recessive, little b, so you put them there. And then you just pair the alleles up. Sometimes you have to make a distinction between an organism's genotype and its phenotype. So the word gene is in the word genotype, so it's the actual alleles or genes that an organism carries. So this is always going to be a pair of letters, so it could be two capitals, two lowercase, or a capital and a lowercase. Phenotype, the PH in phenotype goes with PH in the word physical, so it's what the organism looks like, it's what it physically looks like. So in this case, the organisms can be black or white. So big B, and big B, little b are both genotypes, but both of those make the phenotype that is black. So to get ratios, you have to look at the Punnett square. So in this Punnett square, you make two purple flowers, and they produce offspring. Say they produce 100. 1 out of every 4 is going to be big B. 2 out of every 4 is going to be big B, little b. 1 out of every 4 is going to be little b, little b. That's a 1 to 2 to 1 ratio. So there were 3 possible genotypes, but there's only 2 possible phenotypes, and that's purple or white. So 3 out of every 4 are going to be purple, and 1 out of every 4 is going to be white. So that's a 3 to 1 ratio. Sometimes you need to do what's called a test cross to figure out what the genotype of an organism is. And in that case, the parent usually shows the dominant trait, but you don't know if the second allele is dominant or recessive. So what you do is you mate them to an individual that's homozygous recessive for the trait, and then observe the offspring. So in this case, a farmer has a pea plant with purple flowers. He knows that it's either big P, or big P, little p, but he wants to find out for sure which one it is. So in order to do that, he would take his mystery plant and cross it with one that has white flowers. So the cross looks like big P blank times little p, and the blank stands for the unknown allele. So that's what you're trying to find. So there's 2 possible ways the cross could come out. Either you could get all purple offspring, in which case you know from looking at the Punnett square that your mystery genotype had to be big P, which makes all the offspring hybrids. Or some of the offspring could have been purple and some of them could have been white. Well, the only way to make that happen in a Punnett square is if the mystery parent is big P, little p. So you get 50% white, 50% purple.
So I just explained to you what a Punnett square is and how to do one, and I explained the difference between a genotype and a phenotype. So now what I'm going to do is actually go through 3 practice problems with you, and we're going to work through these together. So on the sheet it tells you that there's a particular animal where black fur is dominant over brown fur. And if you're taking parents who are heterozygous black, predict the genotypes and the phenotypes. And we're going to figure out what percent each one of those is. So the first thing we need to do is find the genotypes of the parents. And they are heterozygous black, which is big B, little b. So we're going to do big B little b times big B little b. So we're going to take this first parent and we're going to put the big B over top of one column and the little b over top of the next column. And then we're going to take the second parent and put the big B next to one column and the little b next to another column. And now all we do is bring them over and down to make pairs. So in this square we have big B, big B. In this square we have a big B and a little b. In this square we have a little b and a big B. And the general convention is if there is a capital letter, you're going to write that first. And in the last square we get little b, little b. So now we've done the square, now we just have to figure out the genotypes and the phenotypes. So we want the percent right here that are homozygous black, or that are big B, big B. Well, there's 4 squares, and one of those 4 is big B, big B, so that's 25%. So 1 in 4, 25%. Heterozygous black is big B, little b. Well, we have one here and we have one here. So that's 2 out of 4, which is 50%. And then little b, we have that right there. And there's 1 out of 4 again, so that's 25%. So these are the genotypes, or the actual genes that are carried by the different organisms. Now, phenotypes, remember, a phenotype is just how it looks. So, the number that are black, well, anything with black fur is going to have at least one capital B. And then the second letter could be either capital or lowercase. So anything with a capital B, there's 1, 2, 3 with capital B's. So that's 3 out of 4, which is 75%. And brown fur is recessive, so that can only be little b, and that's 1 out of 4. That's just that square. So that's 25%. So when you look at these genotypes, 25, 50, 25, well, that works out to a ratio of 1 to 2 to 1. But the phenotypes, you have 3 black for every 1 brown, so that's a ratio of 3 to 1. For the second problem, you're taking a homozygous black and crossing it with a homozygous brown. Remember that homozygous is 2 the same. So black is capital B, so homozygous black is going to be big B, big B. And we're crossing it with homozygous brown, and brown is recessive, so it's little b, little b. So we're going to do the first parent on the top, big B, big B. Second parent down the side, little b, little b. When you line these up, you get big B, little b for every one. So the number that are homozygous black, 0. Heterozygous black, big B, little b, well, they all are, so that's 100%. And homozygous brown, little b, that's 0. Since they all have a capital B in them, they're all going to be black, so that's 100%, and 0% are going to be brown. So with that particular cross, all the babies are going to be black. Now for the last problem, we're doing a heterozygous black times a homozygous brown. And remember, hetero is different, so for hetero, you need one of each, a big B and a little b. And we're crossing that with homozygous brown. Brown is little b's. So we're big B, little b times little b, little b. So we're going to do parent 1 up top. And parent 2 along the side. So you get big B, little b, big B, little b, little b, little b, and little b, little b. So homozygous black, big B, well, we got none, so that's 0. Heterozygous black, big B, little b, well, that's 2 out of 4, so that's 50%. And little b, again, 2 out of 4, so that's 50%. So those are their genotypes. For phenotypes, for black fur, remember, it's just got to have a capital in it somewhere. So 2 out of 4, or 50%, were black, and 2 out of 4, or 50%, were brown. So use these samples as you're going through your practice problems to help you do the problems.